Hello everyone, welcome to Code is Good. In this video, we'll discuss about selection sort. Selection sort is an algorithm which divides the given input array of elements to be sorted into sorted and unsorted partition, like we have seen in bubble sort. We traverse the array and look for the largest element in the unsorted partition, and when it is found, we swap it with the last element in the unsorted partition. Along with that, this was the working methodology of selection sort. Coming to few properties of selection sort, its space complexity is big of 1, which makes it an in-place algorithm. Its time complexity is big of n square, which makes it a quadratic algorithm. Since it is quadratic, so if we have to sort 10 items, then we got to make 100 steps of primitive operations to sort the elements. If we have 100 items in the given input array, then we need to make 10,000 primitive operations to sort the 100 elements. So we are seeing that as this number of input items, they are growing, the number of steps, they are also growing very drastic. So in the long run, it will degrade the performance of selection sort. But it has one advantage over the bubble sort, that compared to bubble sort, it requires less swapping of elements when we find the largest element in each traverse. This we will see in details when we'll do the coding. Selection sort is called an unstable sorting because if we have duplicate elements, then there is no guarantee that their original order relative to each other will be preserved, because on each iteration we swap the largest element with the last indexed element in the unsorted partition. Therefore, there is a probability that we can take the second duplicate value and move it in front of the twin. In this video, we'll also write one small function to demonstrate the selection sort algorithm, which will have its method name as selection sort and will take an array of int elements. We'll also observe that each of the iteration, when we'll complete each iteration, then one item, which will be the largest, will take its correct place in the input array. Let's demonstrate this using an example, that if suppose if the given input array is given as with elements 4, 65, 5 and -1, then how will we sort this array using selection sort? For this, we will use few variables. One is like last index, which will contain the index of the element. Another will be a largest variable, which will have the 0th value at first and will point to the highest number which has been found in the input array, and one variable for iterating the array. So how we'll do? Firstly, we'll see that the last index, since it is an unsorted array in the beginning, so its last index will be 0, 1, 2, 3. So last index is 3. The largest, as we said that in the beginning, we'll consider that the 0th element of the array is the largest. So its value will be 0. And I. So this will be the iterating element. So this will keep it as first, because we'll keep on comparing the largest element with the others. So in each of the iteration, our intention will be to find the largest element in the unsorted partition. As of now, everything in this array is unpartitioned, unsorted partition. So in the first iteration, what will happen that we'll compare 0 with 1 and we'll check if the item present at 0th index is greater than the item which is present at ith index. If it is so that ith element is greater than the largest element, then we will put its value as I. In this case, since it is greater than the largest, so we will increment 0 to 1. Not increment, it is like assigning 1 to largest and then incrementing the value of 1 by 1, which will make it 2. Now we will compare again the 2th indexed element with the one at largest index. So largest is at 1 now. So we'll compare 5 with 65. In this case, the ith element is smaller. So we'll leave the largest as is and we'll increment I by 1, which will make it 3. Now we'll compare ith element with the one at largest index, which is 1. So minus 1 compared with 65, which is less. So we will leave largest as is. And since we have come to the end of the iteration, so our final number is largest is 1 and I is equals to 3. And then we will decrement last index by 1 and make it 2. And before that we will swap the last element index with the largest index. So the new input array will become 4, minus 1, 5 and 65. We observe that the biggest element has taken the last index. So coming back to our iteration. So last index has been decremented by 1, which makes it to 2. Then largest variable will again be 0 and I will be reinitialized to 1. Now we'll do the comparison in this unsorted partition. Now 65 falls in sorted partition, which we were discussing some time back. Now again, we will compare the ith element with the largest indexed element, which is minus 1 compared with 4. And since minus 1 is less than 4, so we will leave the largest to 0 and increment I by 1, which will make it to 2. Then compare second index with the one at the largest. In this case, the ith element is greater than the largest. So we'll assign largest to the I index, which is 2. And since we have come to the end of the iteration, so 2 will be ended over here. And then we will decrement last index by 1, which will make it to 1. And then swap the largest element with the last indexed element. So this will give the array as 4, minus 1, 5 and 65. Now 4 and minus 1, they are unsorted partition, and 5 and 65 are sorted partition. So in this way, we can swap the rest of the 2 elements. And this is how selection sort works. Now let's get down to our ID and do some coding for selection sort. Firstly, We will write a driver method, a main method, which will provide us the input array. Here, this is the input array we'll write. And in this, we'll provide some random numbers. Then we'll call a method called selection sort and pass it the input array for doing the sorting. And then we'll print our array and see if it has been sorted or not. So we'll stream the array, input array, and do a for each on it. So take every number and then print it out. Now let's implement our selection sort. Firstly, we will create a loop which will traverse from the last index. So let's give it as li. It will be the last unsorted index, which will start from the very last. So input.length -1, and it should be always be greater than 0 and will be decremented by 1 in every iteration. Then we'll have a variable called largest, which will be always be initializing with 0, and then a for loop which will do the iteration with largest element. So it will start with 1 and will be going till the last element. So in this iteration, if our input at index I is greater than the index at largest, then we assign the value of I to the largest. And once, when we are done with the entire iteration, then we want to swap our largest element with the last unsorted partition index. So we'll pass on our input array over here, and the largest element index and the last index. So we are done with this selection sort program. If we will run this program, then let's check it whether we get the right output. And as we see that we have got these sorted elements in the given array over here. Thank you for watching the video. Please subscribe to Code is Good and leave out any comments if you have. Thank you.